हेलो एवरीवन, वेलकम टू एलिवेट क्लासेस। आज हम डिस्कस करने जा रहे हैं कम्यूटेटर्स एंड कम्यूटेटर एल्जेब्रा, एंड आई एम आल्सो गोइंग टू डू अ कपल ऑफ प्रॉब्लम्स रिलेटेड टू कम्यूटेटर एल्जेब्रा दैट हैव कम इन प्रीवियस ईयर्स पेपर्स ऑफ जेस्ट एंड TIFR। तो सीधा हम कम्यूटेटर्स के डेफिनेशंस से ही स्टार्ट करते हैं कि कम्यूटेटर्स होते क्या हैं। सो कम्यूटेटर इज अ क्वांटिटी दैट इज डिफाइंड फॉर ऑपरेटर्स। क्वांटम मैकेनिक्स में क्या होता है दैट वी हैव what is known as operators. The operators is something that is very unique to quantum mechanics because we don't really see operators in, let's suppose, classical mechanics. Classical mechanics mein we deal with physical quantities directly, but in quantum mechanics we don't really deal with physical quantities. What we do is we deal with operators corresponding to physical quantities such that, let's suppose, अगर आपके पास एक operator है A and this operator acts on the state or the eigenfunction solution of a quantum mechanical system, then you end up getting usually what is known as an eigenvalue equation, where lambda is the eigenvalue and psi is the eigenfunction solution. तो इसका मतलब ये होता है कि मैथमेटिकली हमारे पास एक ऑब्जेक्ट है, एक क्वांटिटी है जिसको हम ऑपरेटर बोलते हैं, which when it acts on a wave function solution, then we end up getting what is known as an eigenvalue, and eigenvalue is one possible value of that physical quantity if we make a measurement on the system. तो इसीलिए क्वांटम मैकेनिक्स में वी हैव टू डील विथ ऑपरेटर्स. नाउ व्हेन वी डील विथ ऑपरेटर्स, इट इज यूजुअली सीन दैट व्हेन वी डील विथ, लेट्स सपोज, multiple operators, then if I have an operator A acting on another operator B, then it turns out that this may not necessarily be equal to if B acts on A. So only in this respect, therefore, we are going to have to define commutators. So let me first define it and then I'm going to talk about the physical significance and other things. तो अगर हमारे पास एक ऑपरेटर है A and we have another operator B, then the commutator of these two operators A and B, which is defined by A comma B within square brackets, is equal to A acting on B minus B acting on A. That's it. यहाँ पे जो मैं कैप लिख रहा हूँ, it simply signifies that these are operators, which is very different from, let's suppose, observables or physical quantities. Now it may happen that the commutator of these two operators may be 0. If the commutator of two operators comes out to be 0, इसका मतलब क्या है? It simply means that AB minus BA is equal to 0 or AB is equal to BA. If this is the case, then we say that the operators A and B commute. But if this does not happen, if, let's suppose, on the other hand, the commutator of A and B is not equal to 0, in that situation AB minus BA is not equal to 0, therefore AB is not equal to BA. ऐसे सिचुएशन में हम बोलते हैं that the operators A and B do not commute. Now one question may come in your mind that what is the physical significance of these operators and whether or not operators commute or do not commute. I'll come to that in just a moment. Let me define another quantity which is known as the anti-commutator. So commutator को इस तरह से define किया जाता है, but there is also another quantity called anti-commutator जिसको मैं define कर देता हूँ. So the anti-commutator of, let's suppose, two operators A and B is defined as, within curly brackets, A comma B is equal to A operating on B plus B operating on A. Now, before we move on, let me give you a very common example of what a commutator is. ठीक है, मैंने commutator को define कर दिया है, एंटी कम्यूटेटर को डिफाइन कर दिया है. अब मैं एक एग्जाम्पल देता हूं विच इज अ वेरी सिंपल एग्जाम्पल दैट यू एनकाउंटर very much regularly in quantum mechanics, which is the commutator is associated with position and momentum operator. So अगर हमारे पास position operator है और हमारे पास momentum operator है, now you are probably already familiar with both of them. Position operator क्या है? This is the operator associated with the position of a particle in a quantum mechanical system, and this is nothing but x. Now obviously we are only talking about a particle's motion which is restricted to one dimension, इसलिए मैं position को सिर्फ x ही मान के चल रहा हूँ. And the momentum operator corresponding to this direction, ये है, this is the operator associated with the momentum physical quantity, और इसका जो value है, this is nothing but minus I h cut d upon dx. क्योंकि यहाँ पे सिर्फ मैं वन डायमेंशनल मोशन से ही रिलेटेड डिस्कशन करूंगा, सो आई एम टेकिंग इट एज अ डी अपॉन डी एक्स हियर. नाउ व्हाट हैपेंस व्हेन वी ट्राई टू फाइंड आउट द कम्यूटेटर ऑफ x and px? It's very interesting. Let's try and see what we get. So let's say that we apply this commutator onto some state or eigenfunction solution. इसमें सिर्फ मैं definitions को use करूंगा. So what is the operator associated with x? It is just nothing but x. What is the operator associated with px? This is minus I h cut d upon dx इनका commutator acting on psi. Now what is this? This is nothing but x acting on minus I h cut d upon dx minus I h cut d upon dx acting on x times, now this is a normal bracket, psi. Now यहाँ पे जो order है ना ऑपरेटर्स का वो बहुत इंपॉर्टेंट है, बिकॉज एज वी आर सीइंग दैट ए बी इज नॉट नेसेसरली इक्वल टू बी ए, देयरफॉर हम ऑर्डर्स को ऐसे अपनी मर्जी से इंटरचेंज नहीं कर सकते. सो यू हैव टू कीप इन माइंड हाउ द ऑर्डरिंग ऑफ दीज ऑपरेटर्स आर डन एंड यू हैव टू मेंटेन कंसिस्टेंसी in that aspect. तो इसको अगर हम सॉल्व करेंगे तो what do we get? So here I will get minus I h cut d upon dx of psi. So this is nothing but d upon dx of psi. और यहाँ पे हमें मिलेगा plus I h cut d upon dx of what? Now d upon dx में यहाँ पे एक और क्वांटिटी आ जाता है x. So if I say this is x times psi, उसके ऊपर ये ऑपरेट करेगा because the operation happens in sequence. Okay, पहले x will operate on psi, फिर d upon dx will operate on x and psi. So this is nothing but equal to minus I h cut d psi upon dx plus I h cut. Now यहाँ पे एक x रह गया था, let me just write down the x, I forgot the x, minus I x h cut, और यहाँ पे भी एक x था minus I x h cut. So minus I x h cut d psi upon dx and the other quantity is minus I h cut psi dx upon dx. So clearly these two quantities are exactly equal and opposite and cancel out. So बचा क्या हमारे पास? What is remaining is minus I h cut psi. इन दोनों को अगर हम कंपेयर करें x, px ऑपरेटर का जो कम्यूटेटर है acting on psi, I can finally conclude that the commutator of x and px, which is a momentum operator corresponding to the x-axis, is equal to minus I h cut. Wait, there is no minus sign here. यहाँ पे कहाँ minus sign है? Why am I writing minus sign? There is no minus sign here. So this is the commutator of x and px. So what does this mean? Okay, commutator of x and px का मतलब ये है that the momentum operator and the position operator do not commute. Now in quantum mechanics, when operators do not commute, it automatically signals that there is a corresponding Heisenberg's uncertainty principle associated with those two physical quantities. तो इसके लिए मैं एक generalized Heisenberg's uncertainty principle की बात करूंगा. जो generalized Heisenberg uncertainty principle है वो क्या कहती है? What does it say? It simply states that if there are two operators, let's suppose A, and if there is another operator B, then the uncertainty associated with A and the uncertainty associated with B is always greater than equal to 1 upon 2i absolute value of the expectation value of the commutator of the operators of A and B. This is the statement corresponding to the generalized uncertainty principle. Now what happens if I apply this concept to x and px? इसको करके देखते हैं. अगर a x है, let's suppose if a is x and अगर b px है तो हमें क्या मिलेगा? What do we get? In that situation we'll get del x del px is greater than equal to 1 upon 2i. This is nothing but the commutator of x and px operators, which is I h cut, and because this is expectation value of constant, this is nothing but 1 upon 2i I h cut. यहाँ पे I and I gets cancelled and we are finally left with del x del px greater than equal to h cut by 2. This is nothing but the Heisenberg's uncertainty principle for position and momentum. इसका मतलब क्या है? It simply means that if you make a measurement of position and momentum in a given quantum mechanical system at the same time, then the uncertainty associated with position and the uncertainty associated with momentum in that same direction are inversely correlated to each other. That means अगर uncertainty in position ज़्यादा बढ़ जाएगा then uncertainty in momentum decrease होगा, और अगर uncertainty in position decrease होगा तो uncertainty in momentum increase होगा. They are inversely correlated according to this particular relationship. In fact, कोई भी commutator अगर हो आपके पास, if there is a commutator, any commutator associated with any two operators A and B corresponding to physical quantities in quantum mechanics, and if that commutator is non-zero, that means there is a corresponding Heisenberg's uncertainty principle associated with them. अगर कोई दो ऑपरेटर है जिनका कम्यूटेटर नॉन जीरो है, that means their uncertainties will be inversely correlated to one another. That means किसी भी physical system में दोनों को absolute accuracy के साथ measure नहीं कर पाएंगे. This is the physical significance of what commutators mean and what they signify in quantum mechanics. अब बहुत ज़्यादा हम theoretical discussion में नहीं जाते हैं. I know that you are interested in solving various problems related to commutators. तो उससे पहले मैं कुछ identities बता देता हूँ associated with commutators which are very simple to demonstrate as well as easy to remember, which are going to be very helpful in your exams. तो हमने commutators का definition दे दिया, anti commutators का definition दे दिया, momentum और position का जो commutator है we figured that out, and I also gave you the generalized Heisenberg's uncertainty principle. अब मैं कुछ identities बताने जा रहा हूं आपको related to commutators. पहला property है anti-symmetry, which simply means that the commutator of A and B is equal to the negative of the commutator of B and A. It is very easy to demonstrate. You can pause the video and just do the calculations roughly in your notebook and you'll see that this is very easy to prove. Next is the property of linearity. Linearity का मतलब है if we find the commutator of a operator and the sum of operators, let's suppose एक है A, दूसरा है B plus C plus D, then this is equal to the sum of the respective commutators. So A B एक commutator हो जाएगा, दूसरा होगा A C, तीसरा होगा A D. In a similar fashion, you can try to find out the commutators for any other combination of operators also. Then comes Hermitian conjugate, which simply states that if you have a commutator A and B, उनका जो Hermitian conjugate है, this is equal to B dagger, A dagger. आपको पता होगा Hermitian adjoint क्या होता है, right? If you have an operator A, then Hermitian adjoint is specified by A dagger. And if the operator is Hermitian in nature, then A dagger is equal to A. Alright, next is a very important property जो बहुत ज़रूरी है, इसको आपको याद रखना पड़ेगा because this is going to be very useful in certain kinds of problem solving. This is called distributivity. This tells us about the commutator of product of operators. So if you have an operator A and if you have the product of operators B, C, इनका अगर हम commutator find out करना चाहते हैं, this is essentially B times the commutator of A and C plus A commutator of A and C times, or rather commutator of A and B times C. So please keep in mind कि let's suppose this is B, then B जब आप इसको remove करेंगे तो उसी order में उसी side आप इसको remove करेंगे, ठीक है, outside the brackets. And C जो है इसको जब आप remove करेंगे तो उसी direction में आप remove करेंगे. And then it's easy to remember it like this. So similarly अगर हम A B प्रोडक्ट का कम्यूटेटर C के साथ फाइंड आउट करते हैं, देन दिस इज नथिंग बट A कम्यूटेटर ऑफ B एंड C प्लस कम्यूटेटर ऑफ A एंड C B. आई होप दैट यू अंडरस्टैंड इट नाउ. अगर ये A है और अगर ये B है तो A आपका बाहर आ जाएगा लेफ्ट हैंड साइड में और B जब आएगा राइट हैंड साइड में आएगा. सो दीज आर द डेफिनेशंस ऑफ कम्यूटेटर्स एज वेल एज सम प्रॉपर्टीज एसोसिएटेड विद कम्यूटेटर्स. Let us do a couple of examples that have come in previous years TIFR and JEST question papers. अगर आपके पास notebook है, you can pause the video after I give you a question and try it yourself and then cross-check with my answer. Let's start with an easy question, okay? सबसे पहले मैं easy सवाल देता हूँ आपको. Let's start with an easy question. So this is the question: find out the commutator of x and dy dx. If you have a notebook, you can pause the video right now and try to solve it yourself. And once you obtain the answer, mark one of the options and then check or cross-check with my answer. So let me start. तो हमें कम्यूटेटर फाइंड आउट करना है x और dx का. So what we do is we apply it or operate it onto psi being a state. Then I apply the definition of commutator, which is x acting on d by dx minus d by dx acting on x acting on psi. So how does this work? Well, there is a certain ordering of how operators act on one another, right? So as I just now said, first x d by dx, this acts on psi, and then the second example d by dx acts on x times psi. तो ये क्या होगा? This is equal to x d by d psi upon dx minus x d psi upon dx minus psi dx upon dx. तो यहाँ पे these two terms are exactly equal and opposite. They cancel each other out and you are left with minus psi. So what do we get? X comma d upon dx commutator acting on psi is equal to minus psi. तो इसलिए हम कह सकते हैं that the commutator of x and dx is minus 1. So essentially your answer is minus 1, option number C. Let me give you one more question. This question has come in TIFR examination. So this is a question that has come in TIFR 2014 examination. The product Mn of two Hermitian matrices M and N is anti-Hermitian. It follows that option A, anti-commutator of Mn is 0, option B, commutator of Mn is 0, option C, M Hermitian adjoint is equal to N, and option D, M Hermitian adjoint is equal to inverse of N. You can pause the video right now, try the question yourself, and then come back to the video to recheck your answer. तो यहाँ पे क्वेश्चन में हमें दिया क्या है? They are saying that M and N are two Hermitian matrices. Now what are Hermitian matrices? So without going too much into detail, the basic definition of Hermitian matrices is that if I take M dagger, which is a Hermitian adjoint, this is equal to M. That means it's Hermitian. Anti-Hermitian मतलब minus sign आ जाएगा. If I take N Hermitian adjoint, this is equal to N. This is given in the question. They are Hermitian by property, by definition. This is what it is. Now they are saying that the product of M and N is anti-Hermitian. That means if I take the M and N product ka dagger, this is equal to minus Mn. Alright, because it's anti-Hermitian. Now what happens if you take the Hermitian adjoint of the product of operators? So if you have an operator A, B and you take the Hermitian adjoint, this is nothing but B dagger, A dagger. Okay, इनका sequence change हो जाता है. So this is nothing but N dagger, M dagger is equal to minus Mn. But because M and N are Hermitian operators or matrices, so therefore this is equal to N, this is equal to M is equal to minus Mn. तो finally हम इसको लिख सकते हैं Nm plus Mn is equal to 0. Now what is Nm plus Mn? This is the anti-commutator of M and N. Okay, Mn को अगर आप पहले लिखेंगे तो it fits the definition. So this is equal to 0. So therefore the correct option is option number A. The anti-commutator of M and N is equal to 0. So you see, you understand the definitions of what commutator, anti-commutator is. It automatically simplifies many questions. एक और question करते हैं. Let's move forward. This next question is from JEST 2018. इसको एक बार मैं पढ़ देता हूँ. Consider to canonically conjugate operators x and y such that xy commutator is equal to I h cut this identity operator, where I is the identity operator, if x is equal to alpha 1 1 q1 plus q2 and y is equal to alpha 2 1 q1 plus alpha 2 2 q2, where alpha I, j are complex numbers and q1 q2 commutator is equal to zi, the value of these constants alpha 1 1 alpha 2 2 minus alpha 1 2 alpha 2 1 is equal to how much? ये JEST 2018 का question है, तो you can pause the video right now and try to solve it yourself, and once you're done, to cross check, you can come back to this video and look at my answer. If you understood what I have been talking about in the last some time in the video. I have talked about the definition of commutators and I've talked about certain identities involved with it. If you understood those things, this problem is not very difficult. It's very straightforward. तो हम start करते हैं with what is given to us. हमें दिया गया है that the commutator of x and y is equal to I h cut. Identity operator है, इसको आप लिख भी सकते हैं, नहीं भी लिखेंगे तो it doesn't really matter because it behaves as 1. So what is x? X is already given to us, alpha 1 1 q1 plus alpha 1 2 q2, and what is y? Alpha 2 1 q1 plus alpha 2 2 q2. इसका जो commutator है, this is equal to IH का, this is given to us. So let's apply the commutator formula, straightforward. काफी सारे terms आएंगे, we will resolve it, no issues, right? So alpha 1 1 q1 plus alpha 1 2 q2 times alpha 2 1 q1 plus alpha 2 2 q2 minus, अभी reverse आ जाएगा, alpha 2 1 q1 plus alpha 2 2 q2 and this acting on alpha 1 1 q1 plus alpha 1 2 q2. This is nothing but equal to IH cut. Now we have a lot of terms here. Let us simplify these brackets, remove these brackets and look at all these terms involved. So starting में अगर if this acts on this, the quantity we get is alpha 1 1 alpha 2 1 q1 q2. Now if this quantity acts on this quantity, what we get is alpha 1 1 q1 alpha 2 2 q2. इस तरह से if I simplify the entire expression and remove out each individual term, then I should get something like this. Now here some of these terms are equal and opposite, so we can cancel them out. So the fourth term alpha 1 2 alpha 2 1 q2 q2 and the last term alpha 2 2 alpha 1 2 q2 q2, they get cancelled out. Now if I take some quantities common like alpha 1 1 alpha 2 2 यहाँ पे है, right? If I take this common, then what should we get? Alpha 1 1 alpha 2 2 and this becomes q1 q2 minus q2 q1. So this itself is a commutator, right? एक छोटा सा मैंने mistake कर दिया था यहाँ पे. The fourth term was supposedly alpha 1 2 alpha 2 2. यहाँ पे alpha 2 2 है. And anyways, they are getting cancelled out, so no issues. And one additional mistake was this is the actually q1 q1. Okay. Alright, so these two will also get cancelled, alpha 1 1 alpha 2 1 q1 q1 alpha 1 1 alpha 2 1 q1 q1. So हमें बचेगा, we are left with alpha 1 2 alpha 2 1 q1 q2 minus q2 q1. I think this is fine. So this is equal to IH cut. तो यहाँ पे ये एक और commutator बन जाएगा, alpha 1 1 alpha 2 2. This is the commutator of q1 and q2, right? Minus alpha 1 2 alpha 2 1. This is the commutator of q1 and q2, right? So this is equal to IH cut. Already it is given to us in the question that the commutator of q1 q2 is z. Okay, so if I substitute this here, this becomes alpha 1 1 alpha 2 2 z minus alpha 1 2 alpha 2 1 z is equal to IH cut. So finally we get the answer alpha 1 1 alpha 2 2 minus alpha 1 2 alpha 2 1 is equal to IH cut upon z. So the correct answer therefore is equal to option number B. This is the correct answer. So as you can see, these are the kinds of questions that may come in examinations like JEST, TIFR, IITJAM. So if you understand what commutators are, you understand some of their properties, then you should be able to solve questions like these very easily. तो आज के लिए इतना ही. That is all for today. Thank you very much. I am Divya Jyoti and this is Elevate Classes. I'll see you in the next video. Thank you very much. Have a nice day.